Good afternoon, everyone. Am I audible?
Yes, sir.
Okay. Um, okay, we'll just slowly start for the day. Yesterday, we were discussing conditional operator at the end. The last topic we discussed was conditional operator. It is a ternary operator. That means three operands are there. And the syntax is like this. Expression 1 followed by a question mark. Expression 2 followed by a colon. Expression 3. Semicolon is there at the end of all expressions normally. So it's a ternary operator. Three operands are there. If expression 1 is true, normally this will be a relational expression, a simple relational expression or a compound relational expression, which will result in either true or false. If this is true, this will be executed. Otherwise, this will be executed. And we saw two applications: finding the larger of two distinct numbers. This statement is will find the larger of two distinct numbers. This is expression 1, this is expression 2, this is expression 3. And at the end of execution of this statement, z will be having the larger of the two variables a and b. Okay, larger value of two variables a and b. Then we saw finding the absolute value of a given number, given integer. So if x is less than 0, this is the expression 1. If it is less than 0, the true part, this will be executed. It will multiply it with -1. Otherwise, the same number. For a positive number, absolute value is same number only. That will be assigned to z. Otherwise, x into -1 will be assigned to z. In any case, we get the absolute value of x in the variable z. Okay, x value will not change. Okay, next topic is, yesterday just I had given a first view of this. Next topic is bitwise operators. So far all the operations we studied, say addition, a plus b. A is an integer, b is an integer. The whole value, a may be storing in the value say 5, b is having the value 15. When we are performing the operation, these two values are taken and the operation is applied on the value as a whole. So 10 is made of so many bits, ones and zeros, and 15 is, or 15 is made of so many bits, 5 is also made of so many bits. But we are not bothering about the individual bit values. We are taking the value as a whole for that number or for that integer. So all the operators we studied so far, it was applying on the whole value of the variable, without bothering about what bits are there in those values. Okay, now bitwise operators, against the previous operators, it will act on a bit level. That means as a programmer we get control over the individual bits, or we are going to apply something on the individual bits of a number. A variable a has 5, it has a corresponding binary format made of some zeros and ones. We are going to apply some operation on the bit level of a number or of a data value in general. Okay, so bitwise operator act on bit level in a data item such as integer variable, integer constant, etc. Then bitwise operator can work on floating point numbers, and these are the bitwise operators. Syllabus, it may be there only 5, or there may be this is a simpler this is a simple bitwise operator. So first one, shift left. It will shift the left bit sequence of a number towards left. This will shift the bit sequence of a number towards right. We'll see what it means. Then this is bitwise AND operation. We studied logical AND applied on two operands. Logical AND operation, which was using two ampersand symbols. But for bitwise AND, only one ampersand symbol is enough, and it will perform the AND operation on individual bits. This will perform OR operation on individual bits. We studied logical OR, which was having two vertical lines. That will apply the operation, logical operation, on the entire left operand as well as right operand, not on a bitwise. Here it is applied on a bitwise. Then bitwise exclusive OR. and bitwise complement. We will see what all of these are. Okay, and operation, logical and operation, you are familiar. If both inputs are true, the output will be true. All other case, the output will be false. For logical, or if any one of the input is 1 or true, the output will be true. Okay. Now we'll see in detail each of these operators. Okay, before going into that, I just want to refresh your memory. When we created a variable, I told that whenever we execute a statement like this, int x is equal to 1, some bytes are reserved in the memory. If the size of an integer is 2 bytes, 2 bytes will be reserved here. This is the view of the memory, and 2 bytes are reserved. The binary equivalent of this number will be stored, the value stored in x, that will be stored in the memory in binary form. The binary equivalent of decimal digit 1 will be stored here. You can see it here. 8 zeros. I am assuming that integer is 2 bytes here. That means 16 bits. So all the 15 bits 0 and the last bit 1. That is the binary representation of 1. Binary representation of 31 is here. Binary representation of 1 is here. Assuming that an integer is having memory or size 2 bytes. If it is 4 bytes, there will be 32 bits, like that. Okay, now for explaining bitwise operators, I am going to assume an integer is of 1 byte size, similar to a character. Just for demonstration, I am going to assume an integer is of 1 byte, no other difference, it is 1 byte. So instead of this, when I am assigning x equal to 1, only 1 byte will be reserved. Say byte at index value 1006, 1 byte, and 7 zeros, and which is followed by 1 will be stored there. So my basic assumption, now integer data type is 1 byte, just to demonstrate bitwise operators. Okay, so we'll take up bitwise shift left operator, bitwise shift left operator. Okay, assumption is our integers are 1 byte, integer variables are 1 byte, so that I can draw it like this, 8 bits. 1 byte means 8 bits. Okay, otherwise I'll have to show 16 cells like this. Now it is only 8 cells. I'll have to show 16 cells. That will be tedious. Anyway, concept is same. 16 bits or 8 bits. The concept is same. Now I have a variable int a is equal to 5, and the binary sequence of 5 is this. Assuming there are only 8 bits, the binary equivalent of 5. If it was 16 bits, there will be 8 more zeros in the left side. There will be 8 more zeros in the left side. Since I am assuming that it is 1 byte, 5 zeros followed by 101. This is the binary equivalent of 5. You will learn it in your electronics fundamentals or digital electronics, how to convert an integer into its binary equivalent. Okay. So I am going to perform shift left operation on this variable. So how I will apply the shifting operator, bitwise shift left operator or operator is a binary operator. So I have a left operand as my variable and the right operand is 1. This means the bit sequence of A should be shifted towards left by 1 position. Bit sequence of A, that means this sequence will be shifted towards left by one position. If I do that, this is the output I get. The resultant bit sequence will be this. That means this one is shifted to left towards this position, I get it here. This 0 is shifted to this position, I get it here. This 1 is shifted to this position, I get it here. And at the extreme left, 0 is inserted. So when I am shifting towards left, at the right end, zeros are going to get added. Okay, so this operation is shifting the bit sequence of A towards left by 1 position and storing the resultant bit sequence in B. So for variable B, assume that B is also an integer. So the bit sequence of B will be this. Clear what is meant by shifting left? So this operand will decide by how many position I want to shift towards left. If I put 2, the bit sequence of A will be shifted towards left by 2 position. That means this 1 will reach here, this 0 will reach here, this 1 will reach here, and in the extreme left 2 zeros will be added. Okay, so the simplest case, it is shifting towards by left by 1. Is it clear? Any doubt? This is what we get. Now if I do that, what is the equivalent decimal number? This is a binary. I got a new binary number. By shifting the bit sequence of this towards left by 1 position, I got a new binary sequence. This is corresponding to a different integer. What is the integer corresponding to this binary sequence? Can anyone tell? This is binary representation of some number. This is the binary representation of 5. This is the binary representation of some number. Can anyone tell? This is the binary representation of 10. Okay. Decimal number 10, if you convert it into binary, it will be like this: 1010 at the end, all other zeros in the left side. Okay. Now what values of A? What will be the value of A after this operation? If int A is equal to 5, and after performing this operation, value of A will not change. That means A bit sequence will remain same. That means A will have the value 5. Value of B will be 10, because B has the resultant bit sequence. Value of B will be 10. Is it clear? This concept, shifting towards left, I can show by an example. I have a variable x is equal to 5, and I am shifting towards left by 1 position, and we'll see what is the output. I get 10. Am I audible? Not getting any response from you guys. Am I audible? Hello? Someone respond? Okay. Please respond when I am asking some question, or at least if you don't know, at least questions like am I audible, you respond faster. Otherwise, you are not seeing me, I am not seeing you. You only belief or faith that you are there and you are listening. So sometimes I feel like, oh, nobody is there, and it feels so boring. So try to be as much as interactive. So when I do this, input is A. I told the sequence will be 101. All left side all zeros. Last leftmost bits 101. When I am shifting towards left by 1, the resultant value is 10. If I shift towards left by 2 position, the resultant value is 20. If I shift towards left by 3 position, the resultant value is 40. So when I shift towards left, I am finding a pattern here. When the original value is 5 and shifting towards left by 1 position, it is doubled. I did not compile that. It is doubled. 5 became 10. When I am shifting towards left by 2 position, I get 20. So for every shifting by every 1 position, my number is actually getting doubled. Shifting towards left by 1 position, 5 is doubled and I get the result 10. Shifting towards left by 2 position, the 10 is again doubled, 20. Shifting by 3 position, 5 into 2, 10, 10 into 20, 20 into 2, 40. When I am shifting by 3 position, I get 40. So when I am shifting towards left every time by 1 position, the value is actually getting doubled, or it is as good as multiplying by 2, or same as multiplying by 2. Effectively I am achieving multiplying by 2 every time I shift towards left by one position. Okay. Is shifting left clear? Any question, any doubt? Because all other operators are going to be having same concept, same idea. So if you understood this, the other things are going to be easy for you. Any question or clear? Yeah. 80? Yes. Now that is happening because see every time from my left side a 0 is getting pushed out. That is why I am getting the doubling effect. Okay. Suppose in the bit sequence if I had a 1 here, after the third shift, first shift it will come here. After the second shift this 1 is going to go out. So from the left end bits are going to go out of this pipe. As long as 0 is going out, I don't have data loss. I get a doubling effect, multiplying by 2. But if a 1 is going out, I will not get a doubling effect because a 1 here has a value. You know, in a decimal number or in any binary number, if all zeros are there in the left side, there is no value. All these zeros are having no value. Okay. But the moment a 1 is going, I am losing some high uh, high power value. So it will not have a doubling effect. As long as 0 is going out of the pipeline, I get a doubling effect, multiplying by 2 effect. Okay. So we will move on to the next operator, bitwise right shift. Exactly reverse of what we have seen. In shift left, it is shifted towards left. Now in shift right, the bit sequence will be shifted towards right. That means the rightmost digit will be thrown out of this pipe or thrown out of the memory, and in the left side one new 0 will be inserted. Okay. So same concept, 101. I am shifting towards right by one position. This 1 is going out. 1 and 0 comes here. 0 comes here. 1 comes here. So this is the output. In the left side a new 0 is inserted. When one bit is going out, left side one empty space will be there. There 0 is inserted. Okay. Now what will be the value of A and B? A value will not change. But B get the new sequence is stored in B. This is the output. So when 5 is shifted towards right, I get 1 0. 1 0 is corresponding to which binary decimal digit? This sequence is for equivalent to which decimal number? This is the decimal equivalent of 2. That means when 5 is shifted towards right, I get 2. Okay. So we will see that in example here also. So I'll instead of 5 I'll put maybe 16, or okay, I'll just demonstrate that one. So I'm getting 2. Okay, so I'll start with a bigger number, 10. I shift towards right, I get 5. Shift towards right by 2 position, I get 2. Okay, or I'll take another number, shift towards right by 1 position, I get 8. Shift towards right by 2 position, I get 4. So 16, 8, 4. 6 towards right by 3 position, did not compile, get 2. So when 16 is shifted towards right by 1 position, I got 8. Then again one more position, I got 4. Then again one more position, I got 2. Like that. So again shifting one more position, sorry, 4 position, I got 1. Again shifting one more position, I got 0. So shifting towards right is resulting in what? Effectively resulting in integer division. 16, 8, 4, 2, 1, 0. Integer division by 2. Okay. So when you shifted 5 towards right, I got 2. That means when you divide 5 by 2, an integer division, you are going to get 2. So shifting towards right is resulting effectively resulting in a division. Clear? So hope it is clear. Next I will take the next operator, bitwise AND operation. Logical AND we already studied. We saw the truth table also. 0 0 0 0 1 0 1 0 0 1 1 1. Now it is applied on individual bits, and here we have two numbers, two variables. One is storing 5, one is storing 6. Okay, so bit sequence of 5 is this, as I told. Binary sequence of 6 is this, 101 110. Okay, anyway, left side zeros are not having any value, just like decimal numbers. I am applying bitwise AND operation. What happens is the corresponding bits of both the numbers B and A and B. Corresponding bit means this bit and this bit, it is ANDed. AND operation, logical AND operation is applied on the individual bits. So 1 and 0, I get 0. 0 and 1, the resultant bit is again 0. 1 and 1, that means true and true, I get true or 1. All others 0 0 0 0 0 0 0 0 0 like that. So this is the resultant sequence of A and B, A bitwise and B. Is it clear? And this is corresponding to 4. So input is 5, one input is 5, second input is 6, the resultant sequence is 4. I cannot find a relation, direct relation between this. Okay, so let's not, no division, no multiplication. This is the resultant bit sequence and this is corresponding to 4, decimal number 4. Bitwise AND. Is it clear? Any doubt? So if you want to see that in action, I can put 5, 6 here, X, bitwise and Y, and we will see the result. I get 4. Okay, 110. Sorry, 100. 100. Clear? Any doubt? Otherwise, we'll move on to bitwise OR. Here, instead of AND operation, OR operation is performed on the individual bits. Same thing, C is equal to A bitwise OR B. Previously, I applied bitwise AND B. Now it is bitwise OR B. So here it will become 1 or 0. 1 or 0, the truth table of logical OR operation is 1 or 0, 1. 0 or 1, again 1. 1 or 1, again 1. 0 or 0, 0. 0 or 0, 0. 0 or 0, 0. Like that. This is bitwise OR operation. This is the bit sequence of corresponding to decimal digit 7. Bit sequence corresponding to decimal digit 7. Okay. So if I change the operation to OR, 5 and 6 are the inputs. Okay, what happened? Okay. The output is 7. Okay. Clear? We'll move on to next operation. Bitwise exclusive OR. There is a exclusive OR is similar to OR operation. The truth table of exclusive OR is similar to OR operation with one difference. In case of OR operation, if both inputs are ones or both inputs are true, the output will be true. But exclusive OR, it will be true only exclusively if the inputs are OR. If both are true, inputs are OR in the sense complementary, 0 and 1 or 1 and 0. If both inputs are 1, in exclusive OR you will get 0 as the output. In normal OR operation you will get 1 as the output. This is the only difference between exclusive OR and bitwise exclusive OR and a normal OR operation. So in case of exclusive OR, 1 0 1 0 or 0 exclusive OR 1 is 1, 1 exclusive OR 1 is 0. But in the previous case, for normal OR operation, this was 1. So if the bit sequence are opposite, then only the output will be 1. Bit sequence are same, the exclusive OR will result in 0. 1 exclusive OR 0, 1 exclusive OR 1 resulting in 0, 0 exclusive OR 0 also resulting in 0. Only 1 XOR 0 is resulting in 1 and also 0 XOR 1 resulting in 1. Clear? Any doubt? So we can apply it here, it like this. Caret symbol that is there on the symbol, it's called caret. We can apply and we get this. Okay. Yeah. 1 1 is a binary equivalent of decimal 3. Digits bits 1 1 is a binary equivalent of decimal number 3. Okay. Yeah. One more I had shown here, that was complement operation. Complement operator is a unary operator. What it will do is, it will find the complement of a bit. So if I apply, yeah, here is an example. B is equal to complement of A. What will happen is, the bit sequence of A will be changed in such a way that all zeros will become 1 and all ones will become 0. That is what bit complement. So every bit will be taken from the input of, it's a unary operator. Complement operator is a unary operator. Every bit will be taken and it will be complemented. So ones will become zeros and zeros will become 1. That is the functionality of bitwise complement operator. So that's all about bitwise operators. Any doubt? Otherwise we'll move on to some special operators. We are almost reaching to the end of operators topic. So special operators, there are two examples. One is comma. Even though we are using comma quite frequently in our program, separating here, we used it separating the argument list, input list to printf function. So in fact, it is also considered as an operator in C. So used to link related expressions together, say int x comma y. Those are two variables of integer type. We separated it using comma. Then in looping, we are separating, in for loop, we are separating it this way. We will study about looping later. Now we can have an expression this way, assignment expression like this way also. This is the LHS. In RHS, I have something complex. In the parenthesis, I have x is equal to 10, comma y is equal to 5, comma x plus y. Okay. So this is also possible when I am separating the individual sub expressions by comma. Okay, this is also a valid syntax. So just I wanted to show an example of using comma as an operator, separating operator. So in this case, first this will be computed. This operation, this expression will be performed. That is x is assigned with 10. then this will be executed. Y is assigned with 5. Then on the new values of x and y, this will be performed. And finally, the value of the last expression, in this expression separated by comma, the value of the last expression will be assigned to the LHS variable. So what is the value v is going to get now? Assuming v is an integer, x, y, x all are integers, what will be the value v is going to get? Anybody? I told this is the RHS expression completely, and it has several subparts. So in this sequence, this will be executed first. So x gets the value 10. Second, this will be executed. Y gets the value 5. Then x plus y is computed. X plus y is what? Yeah. So in the sequence, the value of the last expression will be assigned to the LHS. Here we have three expressions, and finally we have LHS equal to RHS. So some value should go into LHS. LHS is a variable. We can store only one value. The value which is going to LHS will be the value of the last expression. You can expect such questions in your Viva and all, Viva or multiple choice questions in your lab and all. You can expect such questions. So here 15 will be assigned to V. Okay. Loop we will learn later. Anyway, I am applying a comma here, then semicolon here. Here also I am applying a comma. So just to show the application of comma operator. Another operator, special operator is size of. We already studied this in the lab. We did a program to find the size of a variable or a data type. Even though it looks like a function name or a keyword, it's actually an operator. Okay. So instead of using a symbol, a operator always need not be a symbol like this. It need not be always a symbol. It can be a reserved word also. Okay, it can be a keyword also. English like word also. So this is also an operator. You know already application of this. So I will get size of integer or size in this is a data type. This is also data type. This is a variable. So I get the size of all this. The output of this operation will be integer. That's why every time I am assigning it to integer, because it is number of bytes. Number of bytes is an integer value. So the output of this operation on any data type will be an integer type, which says how many bytes are reserved in the memory for a variable of this data type or this data type or this variable or this constant. Okay, since it's an integer, it will be 2 bytes or 4 bytes based on the computer architecture. 16-bit machine 2 bytes, 32-bit machine 4 bytes. So two special operators are comma operator and size of operator. With that we are done with operators. So arithmetic operators, relational operators, logical and logical or logical operators, conditional operator, assignment operator, shifting operators, bitwise operators, special operators. We have studied all these operators so far. Now we will move on to another topic called arithmetic expression. Not very new. We have used arithmetic expressions in our programs many times. So a plus b is an arithmetic expression. So here is in the first column there is the mathematical way of writing an expression, algebraic expression, and the corresponding C equivalent is here. So in mathematics we use a cross symbol for multiplication, but in C it is star or asterisk. So A into B minus C. Here mathematics we write like this, a cross symbol between this parenthesis not required, it is implicit, it is multiplication in mathematics. But in C you cannot omit like that. This will be a syntax error. You have to parenthesis anyway you can use, but you have to explicitly provide the multiplication symbol if you are targeting to multiply. So in mathematics we can write like this, but in C we should write this way. The same expression, if you want the same task if you want to achieve, you should write it this way. In mathematics, we write a quadratic formula here like this, quadratic function like this. In C, we have to write like this: 3 into x for 3x square, 2 into x plus 1. In mathematics, we write like this. In C, we can write like this. Okay, parenthesis is optional here because in mathematics also it is optional. We know that division will take place first compared to addition. So whether it is there or not, parenthesis is there or not, x by y will be taking place first in mathematics as well as so examples of arithmetic expressions. Okay. Now from that we go to the evaluation of arithmetic expressions. Okay, somewhat similar to mathematics. We know that if we have a statement like this, first a into b is going to take place. In C also a into b is going to take place first, divided by followed by the subtraction. So the result of this subtracted and C is subtracted from the product of A and B. In mathematics as well as C, it is going to take place. Here also it is explicit. First, in mathematics, parenthesis will take whatever in parenthesis or in brackets will be taken place first. Then again another bracket that will be taken place first, second, and after that the result of this and result of this will be multiplied. In mathematics also implicitly that is happening. Okay. So evaluation of expression means in what order. If you have a compound expression like this, arithmetic expression like this, in what order the individual operations are going to take place. We know some rules are there in mathematics, and there is some slight difference in C compared to mathematics. There is a slight difference. In mathematics we use some rule, right? When division, multiplication, addition, subtraction are involved in an expression, arithmetic expression, which one is going to take place first? Based on some rule it is decided, right? Anyone remembers that rule? How you decide whether multiplication take place first or division take place first? How you decide in mathematics? We use the rule called BODMAS, bracket, then division, multiplication, addition, subtraction, right? So we in the mathematics it is clearly defined: bracket first, then division, multiplication, addition, subtraction. But in C it is not like that, so we have to be careful about that. So we will discuss how the evaluation of expression is taking place. So the general format of an expression or a equation is like this: you have an LHS variable, RHS is an expression. So LHS will be a variable all the time if it is like this. So you can give an independent expression also. Okay, still it will be executed, but normally we will have an LHS side also. LHS equal to RHS. RHS will be an expression. An expression can be a constant, or it can be a simple variable, or a compound expression involving constants, variables, and operators. Okay, so I can say it as call it as a compound expression. All these are examples of expressions. Okay. Now I already told you, first the RHS will be evaluated completely and the final value only will be assigned to the LHS variable. Okay, you cannot have a constant in the LHS. You will get a compilation error saying L value is not a variable, it's a constant. So you have to have a variable in the LHS. That and all I have already told. Now these are some examples. In mathematics, if you take the first one, in mathematics, this will take place first and followed by the subtraction. So product of this C is subtracted from the product of A into B. In mathematics, according to BODMAS, this will be taking place first, right? Division. But in C, it is not like that. In C, this will be taking place first. In mathematics, this will be taking place first. In C, this will be taking place first and followed by the division on the product of these two numbers. Here, okay, there is no conflicting operation. First division will be taking, no multiplication because of the first division will be taking place. Then in mathematics, after that addition will be taking place. Board mass, addition is coming first. So after division, addition is going to take place first. First division, then followed by addition, then followed by subtraction of a minus the result of this operation. But in C, this is going to take after division, subtraction is going to take place first. So it's all confusing, right? It's not very similar to mathematics. Okay. So we'll learn what kind of rules are governing the decision of which sub-expression is going to execute first in C. Okay, this is decided by two rules: precedence rule and associativity rule. Precedence means priority. Every operator like addition, subtraction, division, multiplication, there is a priority or weightage assigned to them. Every operator is assigned with a weightage or precedence or priority, and the execution will be taking place according to that. So in mathematics or in C, I'll say in mathematics, addition is having a little bit higher precedence. Division is having a little bit higher precision compared to multiplication. That is why this is taking place first. But in mathematics, multiplication and division are having same priority or same precedence. Okay. But multiplication and division are having higher precedence than addition and subtraction. Okay. So if your expression is something simple like this, a plus b into d, multiplication is having higher precedence, so this will happen first and followed by addition. Same in mathematics also. So because the precedence of multiplication is higher than the precedence of addition. Every operator is given a precedence or a priority or a level. So the precedence or priority of multiplication is higher than addition, so this will take place. But division and multiplication, they are having same precedence. Okay. So two kinds of rules are required to decide which operation is exactly going to take place first. One is precedence, and whenever the precedence of some operators are matching, we will apply another rule called associativity. Okay. When precedence is matching, we will apply associativity. But if there is no matching problem of precedence, it is clear. We don't need to take associativity. So here precedence is clearly differentiated. Multiplication is having higher precedence. No confusion. With the precedence rule itself, we are able to decide which sub-expression is going to execute first. But the moment there is division or there is a subtraction, the precedence may match. For multiplication and division, precedence is matching. They are having the same precedence in C. Similarly, for addition and subtraction, the precedence is same. In that case, we will invoke or apply associativity rule. Okay. So in C language defines rules for deciding the order of execution in such complex expression. Precedence refers to the priority of operators with respect to choosing the order of execution. Higher precedence, addition, division and modulus operation have higher precedence than multiplication, division and modulus operators are having higher precedence than addition and subtraction. But among these three, they are having the same precedence, and among these two, addition and subtraction, they are also having the same precedence. So if it is same, we will apply the rule of associativity. Okay. Now, when it comes to associativity, there are two types of associativity. One is called left to right associativity. Associativity, there are two types: left to right associativity and right to left associativity. Left to right associativity says if there is a tie in the precedence of operators or match in the precedence of operators, then the operator in the left side should be executed first. That is what left to right associativity. If there is a conflict in the precedence, if two operators are having same precedence level, the operator in the left side should take place first, followed by the one in the right side. From left to right, it should be executed. And the other associativity rule is right to left associativity. If the operator is having right, this is specific to the operators. All operators are not having same associativity rule. Some are having some will apply left to right associativity, and some other will apply right to left associativity. Okay. And for arithmetic operators, addition, subtraction, multiplication, division and modulus, arithmetic operators, the associativity applied is left to right, not right to left. Okay. Left to right is the associativity applied for arithmetic expressions, arithmetic operators. Okay, now we will take an example. My expression is a plus b into c minus d. First we apply precedence rule. According to precedence rule, multiplication is having higher precedence than addition and subtraction. So it is natural that applying precedence rule itself, we get to know which sub expression should be executed first. It will be b into c. Is it clear? First, always we apply precedence first. So by applying precedence, since only multiplication is there, other two are subtraction and addition, which are having lower precedence than multiplication, this will take place first. After this operation, there is a problem. Suppose z is the result of this operation. B into c results in a value z. Now I have a plus z minus d. There are only two operators now, plus and minus. They are having same precedence. In such case, we are going to apply associativity. For arithmetic operators, associativity is from left to right. So which one is going to take place? My expression is now temporarily a plus z minus d. Z is the product of b into c. Which is going to take place first? Addition or subtraction? I am waiting for anybody to respond.
Addition.
Why? According to mathematics rule, yeah, addition is going to take place. But what we are not applying mathematics rule, we are applying associativity rule. Since the precedence is matching, we will invoke or apply associativity rule for arithmetic operators left to right. That means the expression in the left side should be taking place first. The right expression is z minus d. Instead of that, the expression or sub expression coming in the left side should be taking place first. So a plus z is going to take place first, followed by subtraction. The result of this minus d is going to take place. This is as good as putting. Okay. Yeah, same thing. Now one exception is all precedence or associativity rules we can bypass using a parenthesis. Precedence and associativity rule we can defy or bypass using parenthesis. So if I put parenthesis, that is going to take place first. This is similar to mathematics. Brackets are given the highest priority. Whatever expression bracket, it is going to take place, be given the highest priority. So here is a table which defines the precedence and associativity of most of the operators we use. In that, many are not familiar to you, but some are familiar. I can see increment operation, postfix increment operation here. So these are having the highest precedence. This group is having the highest precedence compared to all of this. But within this group, they are having the same precedence. Now next level is this. The precedence of all these operators are lesser than this. Then comes multiplication, division and modulus operator. Then comes addition and subtraction. So here only it is clear that multiplication, division and modulus operators are having higher precedence than addition and subtraction. This is a standard table for C programming language. Most of the languages of programming languages are following this precedence table. So higher in the table means higher precedence, and within this column, within this cell, all are having same precedence. Now here it is obvious that multiplication, division and modulus are having higher precedence, but among themselves they are having equal precedence. So multiplication, division, modulus, they are having equal precedence but higher than addition and subtraction. Now whenever it is matching precedence, the associativity, the corresponding associativity rule to be applied is given here. It is left to right. Even for addition, subtraction, associativity is left to right. Other operators you see left to right. Most of the operators, the associativity, in case of a tie, if the precedence is tied, then only we are going to invoke associativity. In case of tie, most of the operators are having left to right associativity, but some like assignment operator, shorthand assignment operators, they are having right to left associativity. Then your ternary operator, right to left associativity. So as a general thing, most of the operators are having right to left to right associativity, but there are some exceptions. You can remember the exception. Assignment operator is the major operator having right to left associativity, and then ternary operator, then increment in this column. In whatever in this column they are having, this cell are having right to left associativity. Yeah, we will. Okay, this is the subset of that table, the commonly used operators. What is the precedence? Higher precedence, then next level precedence, next lower level precedence, like that. And what is the associativity? Okay, you can roughly try to remember this so that it will be helpful when you are doing programs. Here are some examples, precedence and associativity, how it is going to happen. So here multiplication is tied up. So left to right associativity, this will be taking place first, followed by this. Then result of this is added with this. Again left to right associativity for plus and minus. So result of this is added to this. Then the result of this minus the result of this is going to take place. The last operation to take place is minus. First this one will take place, then this one, then this one, then this one. So any expression is given using the rules of precedence and associativity, you should be able to tell, as at least in the normal arithmetic expressions, you should be able to tell which expression is going to, sub expression is going to take place first. Okay. So we will stop for now and we will join back in the lab. In the lab, we will continue with what we stopped in the where we stopped in the last class, and in between we will try to explain some of this concept and go to the next module of C programming lab if possible. Okay. Okay then. See you in the next class in the lab. Bye.